Very good evening, all of you. Hope you all are doing well. Let's start with today's session. Quick recap of yesterday's session. In yesterday's session, we discussed about Sun Microsystem, right? A company which came with their processor, that is Spark, Ultra Spark, Super Spark, which is specially for supercomputers. Then they came with their own OS also, called as Open Solaris or Sun Solaris, based on Unix operating system, multi-user OS. And they came with their own language, that is Java, object-oriented, then platform-independent language, general purpose language. Then we saw the entire history part, like how in around 1990, James Gosling and his team were given one task to control, write a software which will control electronic devices. Their project name was Green Project. The team name was Green Team. Initially, they thought of using C++. Then they found out some drawbacks in C++. I guess that four drawbacks are clear to you. One, diamond problem, memory leaks, architecture and platform dependent, and last, pointers. So to overcome this, they thought of designing their own language which will be based on C++, but it will not have all these problems. So they came with one language, Oak. Okay, Oak from Oak plant. Then some projects were created in Oak. And meantime, they gave time for Oak to mature. And during that time, Oak Technologies put a copyright claim, and then they were supposed to rename it, right? So they renamed it to Java, from Java coffee beans, because they had a habit of drinking coffee, and especially the coffee of Java Island. Okay. And then they renamed it to Java, then the official logo, cup saucer, then the Duke became their official mascot. And then meantime, 1993, WWW came into boom. But in WW, only plain HTML, static HTML, maximum fonts, colors, images, all that, but it was not interactive dynamic. So they thought of making it interactive and dynamic by using one concept called Java applets. The main benefit of Java applets is it is platform independent. So X person makes it, uploads it on the server, and all the people in the globe can access it and run it on their machine, irrespective what OS they have. Because all the machines in the globe have Java virtual machine to run that bytecode. Okay. And initially to test that Java applet, browser was needed. That time company were not ready to support. Therefore, they created their own browser called as Hot Java, which was initially made in Java only. But later, other companies also started giving their support. Means they started coming with their next version, which was applet enabled. And this was around 1995. And officially, 1995, Java was made available to people, those who want to develop their applications in Java. Okay, so quickly, what I'll do is this all things we have done yesterday. So quickly, we'll go through this timeline and then we will dive into the next important topic. As I said, 1990 at Sun Microsystem, Green Project started, and that project was to write a software which will control electronic devices. Then in 1991, they came with a language, Oak, which was based on C++, but problems eliminated. Getting? In 1992, some projects were made using Oak, applications of Oak, mainly video on demand for television system. For that, they used, then even for some telecom companies, Star 7 and all. Getting? So they used Oak for controlling home appliances and, as I said, television systems, which were controlled using remote and touch screen. Then in 1993, the concept of applets they introduced because that time WW was coming into boom. But WWW was made with all static HTMLs. So how to make it dynamic, interactive? They came with this applets. The benefit of this applets is you develop it on one machine, compile it, you get a bytecode, and that bytecode you can upload it on a server. Okay. And then all the clients in the globe who are connected to that server can request for that applet. The applet will get downloaded in their machine, and their machine's VM will interpret it and show the result in the browser, irrespective their machine's OS. What OS that machine is having doesn't matter. How it is that we will be learning now when we will dive into the features part, we'll come to know more. So suppose in this whole internet, one client is using Windows, another is using Mac, another is using Linux, doesn't matter. Someone created it, uploaded it. These all different clients who are having different OS are asking to the server will download that applet. Their machine's VM will interpret it, and after interpretation, whatever output is there is shown in their browser. Doesn't matter what the OS is. So that benefit, that is Java is platform independent. That benefit they took for making web interactive. But remember, for today's Java version, applet is absolute. Mainly from 17 only that applets are being removed. So today you cannot test and run. You need to have an older version, which is, I guess, rarely available. Like, correct? So this is absolute, but for making web dynamic and all, some other technologies Java people have developed. Getting like servlets, JSPs, and then Spring frameworks and all. This has gone into history. So don't worry for that. And in 1994, they designed their own browser because, as I said, they wanted to test it, right? So to test it, that time browser making companies were not ready to give the support, right? So they came with their own browser only called Hot Java, right? And in which the applets were first time tested. And then in 1995, officially to the public, they announced that no more it is Oak, it is Java. Okay. So they renamed it to Java, and many browser companies also announced their support. The famous is Netscape. That's the reason yesterday I shared one MCQ from Gemini. I don't know how many tried it. Getting, I guess three likes were there, means three thumbs up were there, means only they tried it. It is just to test what was done in that day's session. Means whatever you learned in yesterday's session, based on that only that questions were there, just to recall everything. Okay. So the first browser who gave support was Netscape Navigator, then Internet Explorer, Mozilla Firefox, all gave the support. And then from then onwards, they made Java language its development toolkit, like tools, then the virtual machine, then the libraries, all things they made available to the public and people, those who are from the programming community. They started downloading it, installing, and then they started developing their applications in Java. Getting? So from 1996, you can say the versions of Java are coming, like Java 1.1, 1.2, getting to Java 8. Now we are with Java 26 also. But the stable, they say that is 17 is the stable. But after that also 21 also is there, 24 is there, getting? And 25 is having tremendous new features. I'll tell you that also. While teaching, I'll keep telling you the new Java versions, what all add-on things they have added. Getting? So you can say from then onwards, Java became language of internet, and still it is a general purpose language as well for standalone applications, game development, database applications. Okay, you can create console applications. So many things you can develop. But mainly Java is for internet applications only. Okay? So I hope the concept of or the theory, the history part of Java is clear. I hope you will remember a lot of things like the team, James Gosling, Patrick Norton, Jonathan, right? Bill Joy. Bill Joy is there in the AT&T Bell Labs. He's in the making of Unix also. He in the Unix OS, he created that Unix shell script as well. Okay. So quick confirmation you can give me so that we can move to the next part. Lot many things to learn, as I said. Java is very exhaustive, but highly paid people are Java people, right? Can anyone give me quick confirmation? Just instead of typing in the chat window, better you can just unmute and tell me. Yes, all are attending or
Yes, sir.
sure.
Yes, sir.
Okay, please interact. Huh? Again, I told just don't listen. Just don't come for 2 hours. Listening is there, but you need to be curious also. Keep thinking also. Whatever I'm telling, try to think on those things. Simultaneously, if you're taking notes, well and good. Okay. If you think some important, you can take a screenshot of that part. Okay. Now we will dive into the features of Java. Means what are the qualities of Java language, which is making it so powerful and being used for so many years and still going to be there. Java cannot become absolute. Okay? Just remember, though there are opportunities in Python, JavaScript. JavaScript itself has become a full stack. Is using JavaScript backend, front end, everything can be done, but still Java will survive. It cannot become absolute. So there are many good qualities of Java, which is making it powerful. All we cannot learn now. Initially, to start with programming, some 5 features are there that I'll tell you. Some other features are there that we will learn it in the appropriate chapters or appropriate topics. Okay? As we have to start with the programming concept. To learn those things, initially some features are needed that we will see. So the first feature is Java is compiled and interpreted. Okay. Now, generally, programming languages are either only compiled or they're only interpreted. Java is a hybrid technique. Actually, this technique in Java was copied from the Python thing. Python is the older language than Java. Many people think that Python has come later. Actually, Python got red carpet in 2012 and all. Therefore, from there it took a boom. So people think generally that it has come in that time. But no, Java before Java, Python was invented. So either the languages are only compiled or only interpreted. But now you'll say, what does that compilation and interpretation means? It is the mechanism of translating your high level language code to machine code. Understanding? Because your computer only understands its native language, that is zeros and ones. Okay, I hope you know that. Computer's native language is sequence of zeros and ones. So that is the machine language. It is its native language. But we cannot deal with that language. It is so cumbersome. It is not at all easy for us to deal with it. Therefore, assembly languages came, but then assembly languages also are having their limitation. For every architecture, the assembly set is different. Therefore, high level languages came. So as for our convenience, we are moving from machine to assembly, assembly to high. The semantic gap is coming between our domain and the machine domain. So you have to fill that gap. And that gap is filled by the translators. And compilers and interpreters are types of translators. Remember, their task, compiler you take or you take interpreter. Their task is to take your source code. In your source code, it will check whether there is any syntax, semantic errors. Means it will first confirm that whether the source program is correctly written or not, correct keywords, appropriate semicolons, everything. If it is having any error, it will tell you the error. No, then it will convert to machine code. And then you can give that machine code to the CPU for, because it's in native form. So you can load in memory and you can give the charge to the CPU and you can tell to the CPU that fetch these instructions one by one and start executing it. Getting? So interpreters and compilers are basically translators. Getting? But only their policy, way of translation, policy is different. Quickly, I'll just tell you compilation policy is it will take the entire source code and in the whole source code it will check for error. Getting? Means this is your compiler. It takes the source code and in the entire source code it will find out if there are errors. And if yes, it will give you the errors along with the line numbers. All errors it will tell you. Okay, along with the line number. And no, then it will convert it into the target language. And then that target language is also a file. It is not in a memory. A file is created. The file is stored on the disk. And then the OS will bring this file from the disk in memory, and then the CPU will start executing it. Correct? But the policy is how entire. Like we say, na, there are translators for books. The current generation doesn't read books only. That is the main problem. Kidding. So suppose there Harry Potter series. I don't know whether you have read or not. There are so many books of Harry Potter. Originally, they are written in English, but then Indian authors are there. Those who have translated it into Hindi also, Gujarati also, Marathi also. Getting? So they have translated it not line by line. They have taken the complete Harry Potter book, translated from English completely to Marathi, and then the Marathi version is made available to us. So you're the entire term, not line by line. Correct? And there are some languages. So therefore, I said some languages are compiler based. Like you take C, C and C++, nothing special because every C++ compiler internally uses the same. So C, C++ you take, or you take Pascal, very old language Pascal or COBOL. They're all pure compiler based, compiled languages. They take the source code, find the errors, all errors are told no, convert the entire source code into exe that is on the disk, then the OS loader will bring, execute. Okay, so it is compilation based. And we have interpreter also. So interpreter takes the source code, but statement by statement. It is not going to translate it entirely into machine code. It takes one statement, translates to machine code. This machine code is not also in a file, it is in the memory only, and it is immediately given to the underlying processor for execution. Again, takes the next statement. Now, suppose in that statement there is an error, it will tell the error and halt over there only. It will not tell about the next part. At any point, if there is an error, it tells the error and halts there. And it doesn't convert the whole code into machine code, statement by statement. Therefore, machine code is not in the file form, it is in the memory only. Getting? And in memory only it is executed. So that is the there are many languages which are interpreted based. Like you take modern PHP is there, or very old basic languages there. Beginners all purpose symbolic information code. Basic is very famous language, very old word. Okay. So basic, then we take PHP, they all are interpreted ways. Getting? Now Java, as I said, so some languages are pure compiled or pure interpreted, but Java is a hybrid form. It is pseudo translation, means it follows both the principle. It is having a compiler also and an interpreter. Therefore, we can say Java program performance is not good like compiled, but not poor like interpreted. Correct? So we have a Java compiler. It will take your Java source code, which is a file only. Obviously, it is a file on the disk. Okay, I'm just explaining. Later, we will read it on the slide. It will take your Java source code. Okay, and as it's a compiler, it will follow the compilation policy. Getting so, as I said, na, the translators of books, they take one book, they completely translate it, and then the translated version they bring in the market. We don't get it line by line. But suppose you like you can think our Prime Minister PM Modi when he goes to any other countries, like or he's attending UNO session and all. So that time he's very proud of Hindi. So always he gives the maximum time he gives his speech in Hindi. So that time one interpreter is appointed, and what that interpreter he or she what they do, they listen line by line what he's speaking in Hindi, and then they translate it into the other language and then tells to the other people. Now this is happening automatic because AI is there. So with the help of AI, it is immediately online getting translated line by line and it is delivered to those people. Right on. Previously, I'm talking about. So one person is appointed, that person is listening line by line in the speech and translating to English and then telling to others. There, how it is happening, the translator is not waiting for the whole speech to complete, line by line. Okay, so that is the interpretation policy. Okay, so what Java does both. Compiler will take your Java code, check whether there are any syntax errors, semantic errors. Okay, so syntax means grammatical error, like if you have missed semicolon or you have made use of wrong keyword, it will tell you the errors along with the line number. All errors, because it is a compiler. And then it will translate it not into machine code. It will translate it into a hypothetical machine code. Means a machine code for a machine which is not in reality. You can think like that. Okay. Means it is not a direct native code. You can say it is a abstract machine code, or we call it as a byte code. Okay. So byte code is like a machine code, but not the exact machine code. Means in short, if we say it is like a machine code, but not exact machine code, meaning I cannot directly load bytecode in the memory and tell the CPU that please run. Understanding is not possible because it is not in the native which your CPU can understand. Your underlying CPU will understand. In that form, it is not bought. Okay, so you can say it is a bytecode. The bytecode is a machine code, but machine code for a hypothetical machine, an imaginary machine. Getting? And that imaginary machine will take this bytecode and convert to the real machine code. Okay. But because of bytecode, how we get portability? Just now we saw applets and all that once someone makes the applet and keeps it on the server, then all the clients in the globe can pull it from the server and run it on their machine. That is only possible because of this bytecode concept. Getting? So it will produce a file only, which is the dot class file. Your dot Java will be converted to dot class compilation. So it is going to follow the compilation policy. And then later, this bytecode is given to a Java interpreter. Also, you can call it as a Java virtual machine. But it is not only doing the translation of bytecode to machine code, it does the job of OS also, like memory allocation, garbage collection, thread scheduling. Therefore, we can call it as like a platform. That's the reason we call it as a virtual machine. So first part is the compilation part. Done. Took the Java source code, found errors, no, then converted to bytecode. Now this bytecode is in a file form. That bytecode is later given to your Java interpreter. And as it is an interpreter, it will follow interpretation policy, statement by statement. So it will take statement by statement byte code and convert it into actual machine code and then give it to the underlying processor for execution. Getting? But this interpreter, which is there, is having knowledge of your underlying processor. Like suppose this whole thing is going on Linux and suppose it is i5 processor. So this interpreter is having knowledge of Linux and i5 processor. Correct? Means some microsystem people have developed interpreters for nearly all OS and for all hardware in the globe. Means in the world, as many OS are there and as many architectures are there. For every architecture and OS, this interpreter is existing. And the interpreter is having the knowledge of underlying processor and underlying platform. Understanding? So it will take the byte code and statement by statement, it will convert to machine code. Remember, this machine code is not a file. It is in the memory only. In your primary memory only it exists. So next time if you want to run the code, you don't have to do compilation, only interpretation because you will have bytecode file. So you can take that bytecode and just execute it. So it will take the bytecode statement by statement, convert to machine code, give it to the underlying processor. It will execute it. It will take input, it will give output. Okay. So this is the quality of Java, that Java is neither only compiled nor only interpreted. Like some languages are there. Like if you take C, you give the C code to the C compiler. C compiler will convert the whole C code into a executable. And then that executable you load in memory and run it. But the problem is that executable is platform dependent. If it is a Windows exe, you can run only on Windows. If it is the Linux executable, you can run only on Linux. This is not the case for bytecode. Understanding? Bytecodes will be same irrespective where you compile. So I'm not going to mix up with the next point. In the next feature, we will be learning that. In this feature, you just understand that Java is having both the policy. Correct? Means Java is not only compiled language and not only interpreted. Same policy Python follows. Only there, instead of dot class, there they get dot pyc. And there also we have Python virtual machine. Like here we have Java virtual machine. That is this one. Okay. So concept, I hope you got it. That it is not only compiled and not interpreted. It is both. There is the Java compiler. It takes the Java source code, that is .java, finds any syntax semantic errors. If yes, it will tell you that errors along with the line number. No, then it will convert the whole code into a hypothetical machine code or a imaginary machine code or a virtual machine code, right? Which is also called as a Java executable. Means in case of Java, the dot class, that is the bytecode, is called as a Java executable. But the thing is, Java executables cannot be directly loaded in memory, and the CPU cannot directly run it because still they are not in the native form. So therefore, those bytecodes will be given to interpreter. Interpreter takes the bytecode, statement by statement, it converts into machine code, the actual machine code, gives it to the underlying processor for execution. And when it is executing, it may ask for input, it will produce some output. Okay. So I hope the concept is clear. See, as I said, some languages are either only compiled or only interpreted. As I said, like basic you take or PHP you take, they are only interpreted, right? And there are some languages which are only compiled. Now, only compiled languages like C, Pascal, and all. Java follows both. C, C, Pascal are only compiled language. Like PHP, Ruby, Perl, very old language like Basic. They all are. The Basic is now outdated. Correct? It's another version that is VB.NET and all they have introduced in the .NET framework. So PHP, Ruby, Perl, they all are purely interpreted. But Java is compiled as well as interpreted. Okay. Now, using any text editor means a software through which you can create your source program files. You can save those files. You can reopen that file. You can do editing operations like cut, copy, paste, right or no? So all that activities which you can do in one file, sorry, in one software that is called text editor. Using text editor, you created your Java source file. Okay, whatever name you want, you give it with the extension .java. That source file is given to the Java compiler, right? And as it is a compiler, its task is to do grammar checking. Compilers are like our literature teachers. I don't know whether you had such great teachers or no. My English teacher, Dr. Brinda Balasubramanian, she was the amazingly getting, and she used to make the whole paper red, getting, and such strict checking she used to do. Why? Because she was already so much expert in that language. So, especially our literature teachers, what they do, whatever we write, they check whether it is grammatically correct or not. Same work compiler does. Okay. So, it checks whether your code is grammatically correct. And if there are some errors, it will tell you the errors, if any. Syntax and semantic errors. Now, some may say syntax error, okay, I know. That is grammar mistake you have done. Somewhere semicolon is missing, okay, or some keyword is used wrong. What about semantic error? Semantic means uh, you're not following the meaning of that rule. Like I'll tell you in a very simple way, like in English, if we say the boy ate an apple, okay, so it is grammatically correct. And if I say the apple ate an boy, if I'm exchanging the position of nouns, in place of apple, I wrote boy, and in place of boy, apple. Still, grammatically, it is correct, but the meaning is wrong. It's making funny meaning. No? Just or no? You only just think if I make the apple late and boy. So it is grammatically wrong. In programming, also, it is like that. I'll tell you an example. Like you are writing A equal to B plus C and semicolon. So everything is fine, perfectly fine, nothing wrong. So syntax error is not there. But what happened is it checked the data types of B and C, whether they are compatible for plus. But B is Boolean, okay, and C is integer. So according to Java language, it is illegal to add a Boolean with an integer. That is semantic error. It checks the meaning also. Correct? It is not only checking the syntax, it checks the meaning as well. Correct? So all the things it has done, if there are no errors, it will translate it into a bytecode, which we call it as the Java executable. But only thing is Java executables can never be loaded directly in the memory, and CPU cannot execute it directly because it is not in the actual native form, which your CPU can understand. Getting? So this bytecode, which is like a machine code, but it's a machine code for a hypothetical machine, or it is a machine code for a virtual machine, an imaginary machine. You can think like that. Okay. So this bytecode is formed, but that is in a file form, remember. Therefore, if you want to run any bytecode next time, you don't need to do compilation. Only this bytecode is sufficient. This bytecode is given to your Java interpreter. Okay. And the job of interpreter is to take this bytecode and statement by statement translate it into actual machine code. But now, which machine code this interpreter knows its underlying processor details, because this is the virtual machine for that particular machine on which it is going on. Getting? Means Sun Microsystem people have developed these virtual machines for every system. Like suppose this whole thing, whatever I'm showing, is going on Windows system. So this virtual machine is having the knowledge of Windows because it is going on Windows. But suppose this whole thing is going on Linux. So Linux VM will be different. Remember, Sun Microsystem people have developed virtual machines for nearly all OS and all architectures in the globe. Means today there is no such system which is not having VM. You take a small smart watch, which is a very small device, but it's a smartwatch, right or no? The smartwatch is also having memory, it is having a CPU, everything. Okay. Or you just go little ahead of it, tablets you take, or you go ahead, laptops, your PCs, supercomputers, any size device, if they all are smart, they have CPU, they have OS. So Sun Microsystem has developed for all such systems virtual machines. Getting? And those virtual machines are having knowledge of their OS and their hardware. So if this is the VM of Windows, it is having knowledge of Windows. If this is the VM of Linux, it is having knowledge of Linux. Therefore, it takes the bytecode, converts to machine code, and gives it to its underlying processor for execution. See, but this is happening statement by statement. Okay, so it will give to your underlying platform, processor, you can say OS and your CPU, and what that CPU is going to do. It will run it because now it is in its native form. When it runs, maybe it is giving you some output also. Okay, so I hope the whole process is clear and you can just understand what is the bytecode. So you can say bytecode is called as a Java executable, or it is a machine code, but it's a machine code for some hypothetical machine. Getting? And that hypothetical machine will take this Java executable and bring into real machine code. Okay, so you can say Java executable is in the form of bytecode. Whenever anyone says that this is a Java executable, immediately you should know when that person is saying this is a Java, means it is a bytecode, means it is a dot class. Okay, and you can say it is the machine code for a hypothetical machine. So hypothetical machine code or a virtual code, right? And cannot be executed directly by your machine. Means I cannot give this directly to your processor because it's not in a native form. Who will bring in a native form? This VM. And this interpreter will take that Java executable and convert it into actual machine code. And then the real machine will run it. Okay. So interprets bytecode to machine code and gives it to the underlying processor for execution. Getting? So I hope you're understanding this concept. Okay. So quick confirmation that I hope you got it, that Java is not only compiled or only interpreted. It is both. It follows both the policy. Now, some may have a doubt like why they made this two-step activity. Why not directly? So if they bring it directly, then it will become platform dependent. And their main ultimate goal was what? Platform independent concept. So the bytecode is always going to be neutral. It is not bound to any OS. And they have designed this VM for all types of OS in the globe. And this VMs come along with the OS. Means when you buy a new machine and you install OS, along with the OS, this VM is sure going to come. So as VM is already there with your OS, you can directly run that bytecode on any system because every system will have a VM. So that benefit you get. Okay. So can you tell me quick confirmation you can give that the first feature of Java is clear to you? I hope you have understood
Yes,
what
sir.
is a compiler, what is the interpreter. You think others also answer, like I guess only one person, Shamali only. Shamali only answers, I guess.
Yes,
Others
sir.
also, please, others also keep interacting. Okay, listen me carefully. Whatever 1.5 hour, 2 hours. Okay, listen carefully. Don't simultaneously keep peeping in your cell phone, check your messages and all. You will be distracted. Uh, you'll not do anything thoroughly or perfectly. So when you have decided that I've joined this course, I am going to do it consistently. Getting many people say, like anything if you do consistently for 21 days, then never you will uh, get distracted from it, or you will never discontinue it, right or no? So many are there, which do the things regularly. Many regularly they when they get up in the morning and when they complete their all rituals, they do prayer. Never you forget doing prayer, right or no? Consistent. Some are there, those who consistently go to fitness center, like gyms and all. So they never do excuse. I am going to go to gym from 7 to 9 means I will go means I'll go. Never skipping. So when you follow consistency in all those things, same consistency here you have to follow, right or no? Okay. So if you regularly do it, you will never skip. And I'm sure then once you do it for 21 days, you will attend the sessions regularly. Okay. And at the end, you will sure thank me. Yes, we got to know so many things to learn. Okay. So quick confirmation from others also that Java is compiled and interpreted. That part is clear to you. Yes, Anu, boys, girls, all should answer.
Yes, sir.
Sure, na? Please answer.
Yes, sir.
It doesn't take much efforts, no? Right or no? Or do you spend some money by unmuting and answering me? Or you'll say like, sir should give money, then I'll answer, right? But it should not be like that. Please unmute your answer. Now we will continue with the next feature, right? Or no, we have to quickly start with the programming part. But as I said, I cannot do shortcuts. Okay, we have to go with the procedure. कायदे से जाना है. Okay, so all the things which we have to learn, we have to learn. I cannot skip that part. Moving to the next feature, that is Java is platform independent and portable. Getting many people are confused with this both thing. Both many people think both is one and the same thing. Means you can use the concept interchangeably and all. No. Okay, I'll tell you. I'll give the clear understanding. What does platform independency means? Now suppose you have written one program, a.java, okay, and you are giving it to the Java compiler for compilation. Okay, and Java compiler is not found any error, so it converted into bytecode. Okay, but this thing is happening on a Windows system, suppose. Okay, and I wrote exact same program, same source code, exact same, nothing changed in it. Okay, or rather, this source code only I gave to another system, which is a Mac-based system. Okay, Amiro wala system, you know, rich people use Mac. So what I'm saying, a Mac-based system is there. Mac system will also have its Java compiler, obviously. So if you give the same source code to exact same source code, no change in it. The code is same. And I give it to the Java compiler of Mac. And when Mac Java compiler compiles it and gives you a bytecode, it is exactly same as the bytecode of Windows Java compiler. This is independency. Getting? Means what I want to say, if your source code is same, the produced bytecode is same, irrespective where you're compiling it. Whether you're compiling on Windows compiler or on a Mac compiler. Doesn't matter. Getting? This is not true for C. Na? I hope you know it. If you write a C program and you compile it on Windows, you'll get a Windows executable. Exact same C program or a C++ program, I give to Mac C compiler. I'll get a Mac executable. Those executables are not same, though your source code is same. Means your C++ program which you gave to Windows compiler and the C++ program which you gave to Mac C++ compiler are same, but the produced machine code, the target code executable are different. That is the Windows executable, which can run only on any other Windows system. And this is a Mac executable, which can run only on any other Mac. This is not the case for Java. Getting? So what you have to remember, why Java is platform independent? Why Java is platform independent? Because if your source code is same, the compiled bytecode will be same irrespective on which system you have compiled. Doesn't matter. And I have tested it. I've done it initially, very, very initially when I started learning Java. That time, Java was not that in boom. It was just started using. We started with Java 1.4 and by reading that Herbert Shield and we were doing it. That time internet was also not that cheap to Google and search and all those things. Correct? So using that books and we were doing those programs. Now the availability is so much. You have so many AI tools. You can ask to the AI tool. It will give you guidance. It will give you so many examples and all. Okay, what I want to say is that that time I tested and saw I was having a dual OS. I was having a Linux platform also and the Windows platform. So I compiled the same program on both the platform and I saw the bytecode. It was 100% same, exactly same. Getting? Though I compiled it on different OS. That is platform independency. Getting? So I hope the concept of platform independency is clear. Now, what about portability? Now, this bytecode, if you want to run it, it is a hypothetical machine code. You have to bring it into real machine code. So you will give it to the virtual machine, that is your interpreter. Okay. Now, what this interpreter does, it takes the bytecode, converts to machine code, and give it to the underlying platform for execution. Okay. But remember, this virtual machine is a Windows virtual machine. Therefore, it will convert to such machine code which is bound to Windows. Okay. And the Mac bytecode, when I give to Mac VM, okay, there will be a virtual machine for Mac also, right? Remember, these VMs are not platform independent. VMs are platform dependent. Means this is Windows VM. So Mac VM will be different, guys. Linux VM will be different. You're understanding? Your Android cell phone is there. So it will also have a VM, but actually Android is internally using Linux kernel only, right? So all these OS will have their different VMs. But Sun Microsystem has designed VMs for nearly all OS in the globe. Getting? Therefore, no problem. Every OS is going to have their own virtual machines. And remember, these virtual machines come along with the OS only. Whenever you install the OS, along with that as a freebie, as we say, no? Like when you buy um, when you order a pizza, so along with that pizza, inside that all things are there, no? Like ketchup is there and herbs are there and all those things are put in it. If suppose they don't put, you directly call them, means that 400, 500 rupees pizza has come, but still you will fight for that freebies that you didn't send ketchup and you have not sent the herbs and all. Right or no, immediately you call to those people. So that is like a freebie. Come along with it. Means when you install OS, along with OS, this VMs come. Getting? And please remember, VMs are not platform independent, they are platform dependent because every VM is having knowledge of that platform, okay, and that underlying architecture. Getting? So if it is a Mac VM will take that bytecode and convert to the machine code, okay, and give it to the underlying processor. But this machine code will be Mac compatible and this machine code will be Win compatible. So this machine codes are not same, though the bytecode is same. Okay. Now talking about portability. What does that portability means? It says that if you have compiled any Java code and you have got a bytecode, you can give that bytecode to any VM of the system, of the whole globe. Getting? Means the same bytecode, if I give to this VM, still it will run. Means I have compiled on Windows. I got the bytecode, but I gave it to the Mac VM. And this also I have tested. Huh? I've done it. It 100% works. Getting? So compiled on Windows and you got a bytecode. That bytecode you are giving to Windows VM. Obviously it will run. But the same bytecode, if I give directly to Mac VM, still it will run. This Mac VM will take that hypothetical code and convert to actual machine code and give it to its underlying. And vice versa, this thing. Like if I give Mac bytecode to Windows VM, still it will run. So that is portability. Getting to portability in a very simple term, you can say compile once and run anywhere. Anywhere I'm saying. Getting means write once, run anywhere. Getting this Vora. If you read complete reference by Herbert Shield, latest edition, if you take, in that he has given such, and then in bracket he has given the full form. That is, you write it once, okay, and after writing that once, you got the bytecode. That bytecode you can run on any system in the globe, and that is what they took the benefit for applets. See, one X person makes the applet, so he has developed the applet, compiled them, he made the bytecode, and that bytecode he has uploaded on the server. And all the clients in the globe are asking for that applet to the server. Server downloads that applet in their machine, and their machine VM is running it and showing the output in their browsers, irrespective what the OS those clients are having in the globe. You understanding that benefit they took? Okay. So portability means what you got it, that if you have compiled the Java code and you have got a bytecode, the same bytecode you can run on any virtual machines of the globe, irrespective of the platform and the underlying architecture. Getting? Even you can test it, like you can create a bytecode on your laptop and transfer it to the cell phone. And on cell phones also you can run it. Correct? Because cell phones also have their VM. But generally, people don't know that on cell phones how I can do on a root level, how can I do. So there is a facility. Correct? That cross thing also can be done. And still that bytecode which you created on laptop and you took it on your um, Android cell phone, it will run 100%. Okay, so that is portability. So don't confuse between platform independency and portability. What you'll remember about platform independency? If the source code is same, the produced bytecode is same, irrespective on which system you are compiling. On whichever system you compile, if the source code is same, the bytecode has to be same. That is platform independence. And portability means one bytecode only can run on any system virtual machine. Getting? Means if you have compiled it once, you can give that bytecode to any system virtual machine. And that virtual machine will take the bytecode and convert to machine code and give it to the underlying processor for execution. Getting? And the benefit of this concept is that you mainly get platform independency. Okay. And you get portability. Right? Okay. So, and suppose, for example, your system previously you have compiled your project and you got all the bytecodes. Now, these are your old bytecodes. Okay. But now on the system where you're going to run it, that system is only upgraded. Any hardware configurations are upgraded, or your OS is upgraded. Like previously you were working on Windows and you have removed and you have installed Mac on it. Or whatever you have, or you have gone to higher version of Windows. Getting? So irrespective, if you have upgraded your system, you have upgraded your OS, getting? Then also the old bytecodes you can still run on the new system. Why? Because the new system will also have what? VM. So this new system VM will take the old bytecode, convert to machine code, and give it. So still you don't have to do recompilation or anything. But downward compatibility is not there. Like if you're going to the lower version, like if you have compiled this on Java 17, suppose. Okay. So you can run it on 17 and above versions. But if you take it to some another system where Java 8 is there, then it will say that seems that this bytecode is run in a higher version. It cannot be run in this system. Please recompile it in the new version, in the older version. So downward compatibility is not there. Upward compatibility is there. Correct? So if you have compiled in 8 and you try to run it in 17 or 24, it will run 100%. No problem. Correct? So the feature, I hope you got it. So later, if you are changing your OS or you are upgrading your system, doesn't matter. The old bytecode can be still run in the new system. Getting? Okay, so I hope the concept is clear. There was only one drawback, that is, we need to have VM on all systems. Suppose on some system VM is not there, then we were not able to run the bytecode. Initially, it was there. In the very beginning, there's some people were facing challenges. Like I'll tell you example, IBM systems. IBM people were not ready to reveal the architecture of their system, because if the architecture is not known, how they can make VMs, no? For those OS, like for Windows VM, Mac VM, Linux VM. So they need to have the knowledge of those OS. Then only they can make VMs for it. So initially, this IBM people were very adamant, or they were very reluctant. They were not ready to reveal the architecture so that some people can make VM for IBM. Therefore, very beginning, we were not able to run Java bytecodes on IBM systems. But soon they saw the power of Java. Java was taking, it was coming into power and it was becoming a lot famous. So they realized the power, and then soon they also gave the support. And some people created VM for IBMs also. And therefore, at today's situation, if you consider, there are no systems today which don't have VM. You take a small smart device like your smartwatch to the supercomputer. Everyone is having a VM. Getting clear? And therefore, today we won't have the problem of not able to run the bytecodes on some system. It will be impossible. Every OS in the globe is having ability to run the bytecodes, because every system in the globe is having a virtual machine. Okay, so I hope this concept is clear. Quickly, I'll try to justify it. Fatafat. Okay, so suppose I'm considering this is a Windows system, and on Windows system, I wrote one Java source file. I gave it to the Windows Java compiler, and after compilation, I got the bytecode, and that bytecode I'll give it for execution to Windows interpreter. Getting? And the same thing I've tried to do on Linux system or any Mac system. Okay. So on the Linux system also, I have created exactly same source code. Same thing is there. Whatever logic is written here, the same logic here. Okay. And I gave that source code to Linux compiler and I got a bytecode. And then that bytecode, I give it to the Linux virtual machine, and Linux virtual machine will convert this bytecode to the machine code, which you can give it to the underlying processor of that Linux system. It will run it. Getting? Now here portability means what? If the source code is same, the produced bytecode is same. Understanding? If the source code is same, the produced bytecode is same, irrespective on which system you are compiling. Whether you are compiling on Linux or whether you are compiling on Windows, doesn't matter. If your source code is same, the bytecode has to be same. That is independency. Portability means what? If you have compiled the code on one system, you got the bytecode. You can give that bytecode directly to any other system VM and still it will be able to run. That is portability. See here, Windows bytecode, I'm giving it to Linux VM, or Linux bytecode I'm giving to Windows VM. We are able to run it. That is portability. Portability. Normal in English, portability means what? We can easily move it from one place to another. Right or no? We say it is portable. Means laptops are portable, tablets are portable, but your PC is very difficult. No? It is very difficult to move from one place to another. Portability is less. Portable meaning what? Moving from one place. Therefore, there are some service providers. No? They take your things from your doorstep and give it to the other people. They call it as no? Porter is the porter, I guess, right? So what they're doing, moving only from one place to another. Exact same thing. Now you're moving this bytecode from this system to another and giving it to that VM. Still, it will run. In short, if you have compiled it on one machine, that bytecode you can give to any machine in the globe. Every machine will be able to run it because everyone is going to have their interpreter. And that interpreter is having knowledge about that system. Huh? Interpreters are not independent. Every interpreter is bound to that OS. Windows VM is different, and Mac VM is different, and Linux VM is different. Okay, so I hope that part is clear. Just I forgot to put animation so that I put quickly. So that we'll go through this point which I told. The same thing we will read. And all these PPTs I make on Google Slide. I don't use Microsoft product. Okay. Because generally nowadays you should prefer all cloud-based system. Okay. Because it is safe kept over there. Like if you sell your laptop or by some means, some bad sectors have come on your hard disk, everything will be lost. Better to keep it on the cloud. Okay? So whatever work you do, good practice, keep on cloud. uh, Even if you do your Java programs, try to sync it with GitHub. So try to keep all the programs on GitHub. So by some means, if you lose it from your hard drive, no problem. They all are there on your GitHub storage. Okay? Okay. So talking about platform independency, as I said, when the source code is same, the produced bytecode is always same, irrespective on which system it is compiled. Whether you have compiled on Linux or Windows or Mac, if the source program is same, the bytecode is same. This is not true for C++ or a Pascal program. If you compile a C++ program on Windows, you get a exe. If you compile the same C++ on Mac, you get a Mac exe. They both are not same. Getting? That is the concept. And what is about portability? Portability means if you compile once, you can run that bytecode on any VM of the globe, irrespective of your platform. So compile once, run anywhere. Okay. And portability gives you benefit that if you have compiled it already and now you have upgraded your system, means you have upgraded OS, you have upgraded some hardware configuration. Then also the old bytecodes you can run in the newer system. That is the main benefit you get. Okay. So the same bytecode can be executed on any VM, irrespective of the platform. That is portability. Getting? Suppose in the future, if you are doing some system upgradation, like you're changing OS or some system resource, like you have added some graphics card is added, or you have added, uh, for example, you have added some more RAM chips and all. Doesn't matter. Okay, the old bytecode can be run on the new system because new system will also have VM. I told you, it is by default. It comes as a freebie. When elections come, then they announce freebies like कि हमें वोट दो ये फ्री मिलेगा वो फ्री मिलेगा ये मिलेगा तो that is so when you install OS के साथ ये VM आता ही है by default. Correct? So you don't have to recompile your old project. The old bytecodes can be run successfully. Okay, and this also gives benefit. Okay, this bytecode concept gives benefit that you can run same program anywhere in the globe. Same program can be run anywhere on the globe. So it is giving benefit to the internet also. And that is the reason it has become language of internet. Getting? Because of compile once and run anywhere. You compile it once and run anywhere, it has become a language of internet. Getting? Why? Because internet is made up of connection of heterogeneous machines. Is internet made up of all homogeneous machines? No. In the whole internet, some are using Mac, some are using Windows, some are using Linux, some are working on workstations. Getting? Doesn't matter. Still, you will be able to run it. Okay. And one more benefit that all the data type sizes and also they have tried to keep it consistent. Means OS to OS, the data type size changes and all, nothing like that. If int takes 4 byte, everywhere it is 4 byte. On Mac also 4 byte, Windows also 4 byte, Linux also 4 byte. Getting? Only there was one limitation. I told you. Can anyone tell me what was the limitation, which is no more a limitation for today's day? Let's see if you have heard me carefully. Can anyone tell me what was the limitation? Initial, in very initial stages of Java. Can anyone? No? Not a single person? No? Shamali, others are there. Many are joined. Don't remember? If you have heard me carefully, I told you, in the very initial days, the Sun people were facing problems. What the limitations are? That for every system in the globe, you need to have what? VM. Getting? If the VM is not there on that system, we won't be able to run that bytecode. Getting? And as I said, in the very initial days, like for some systems like IBM, for IBM systems, they were not able to make VM because IBM was not ready to reveal the details, architecture details, so that they can make a VM for that system. You understanding? Clear? So the
Yes, sir.
problem is you need to have VM. But as I said, for today's day, this is no more a problem. Sun Microsystem has developed VM for nearly all systems in the globe. Let there be Mac OS, let there be Windows OS, let there be Linux OS, or it is an Android. Android is internally a Linux kernel only. Okay. Any OS you take, for every OS they have made VM. Therefore, no more we will have that problem. So limitation was every platform should have VM. And providing VM for every platform was the job of responsibility of Sun Microsystem. Getting? So this won't be a problem today. See here, no more this issue because every system is having a VM. Means whenever you install OS, along with the OS only, they are packing that VM also and providing. That is, Sun Microsystem has developed VMs for all OS. And that VMs are having knowledge about those systems. Means if it is a Mac VM, it will have knowledge of Mac system. If it is a Windows VM, it is having knowledge of Windows. Getting? Now, some may say, don't they make one VM only, which is having knowledge of all the OS? VM will become bulky, na, guys. It will be a bulky size VM. Therefore, they have created like that, that it is a VM for every system separate. Getting? Meaning one VM only having knowledge of all platform. Then that VM is also a program only, no, which is doing translation. The size of that VM will become more. So it should be a lightweight. Therefore, for every OS, a separate VM is made. Okay. So give me quick confirmation about this. If this feature is clear, others are also attending or no, others are listening to me. Just at least tell me with yes, no. Okay.
Yes, sir.
Yes, sir.
Sure, no, others, I never listen, I never hear any noise from boys. Are boys also attending or no? Yes, Garv was attending, I guess. Then Nishant is attending. You also should answer. Okay, only girls attend. Then they only crack interviews and then they get the jobs. And then you say, these girls don't keep any job for us. It's not like that. Everything is skill based. If you're skilled, you're confident, you get job. Okay. Quickly moving to the third feature. Okay. Third feature, I'll tell you. So both the features are clear now that Java is compiled and interpreted and Java is platform independent and portable. Okay. Moving to the third feature, that is Java is object oriented. Okay. Now Java is a true OOP. There are some languages which are pure OOP also. Java is not pure OOP. Why? I'll tell you the reason. But it is a true object-oriented programming language. Why? Because in Java, everything is to be encapsulated within a class, correct? Whatever name you give, but everything like your data, then the methods, okay? And even main is also supposed to be the part of that class. And main is which function? The entry exit function. Means your application execution start with main and complete with main, like C and C++. Okay, we will be talking in detail about it, don't worry. But the thing is, the main is also part of the class, which is not in C++. C++ main you have to keep outside of the class, right? Here, everything is to be encapsulated. But now from Java 25, the rule is changed. You can directly only write main. Okay, but then you'll say then has it spoiled the definition of O? Yeah, it is someone else which is going to wrap it in a class. For us, they have made it easy, the programmer. For programmer, they have tried to make it more of like a scripting language, like JavaScript or PHP, that you only focus on this thing, main and all. You don't bother about wrapping it in a class. Someone else is there which will wrap it. But before 25, version 25, it is mandatory. Actually, today also it is mandatory, but we don't do it. Someone else does for it. Getting? So why Java is a true OP? Because everything is to be encapsulated within a class. Your data, your methods, your mean. Okay. And then you create objects of it, and then those objects interact with each other via method. Okay. So therefore, we call it as a true OP. Okay, you cannot call it as a pure OP. Why? Because still we have some things, okay, which are not yet object. When a language is called pure OP, in which everything is the object, each and everything is the object. Best example is Python. If you take Python, it's a pure OP. There, a simple integer is also object. Getting a float is an object. Everything is the object. Okay. In Java, there are some primitive data types. 8 primitive data types are there. They are not object. They are primitive only. You cannot treat them as the object. There is int, sorry, byte is there, short, int. long, float, double, boolean, and char. They are primitive, they are not object. If you want to represent them as an object, then they have given a wrapper classes, and using wrapper class, you will represent that primitive as a object. Means you'll wrap your primitive values inside that object and then treat it as object. But by default, it is primitives are primitives only. But as I said, some languages automatically they are objects. Their everything is an object. Their function is also object only. Getting? Therefore, we cannot call it as a pure OP, but still it is a true OP. Why true OP? Why true object oriented? Because everything you put within a class. Getting? And moreover, you should remember that Sun Microsystem, those people also have developed hundreds of ready classes to make our work easy. They have reduced our burden. We don't have to develop all those things from the scratch. Getting? They have developed so many things already. Like you want to deal with data structures. Getting? So they have created a linked list class, a map class, a set class, a stack class, a priority queue class. All they have already developed. Your task is just to create an object of their class and use it. Getting? Like suppose you want to create a UI, standalone UI you want to create, like a window, a button, a text box. For that, ready-made classes are there. Understanding? You want to deal with networking. You want to write a socket programming. So for that, classes are there. Okay. You need the basic activities like you want to deal with strings, threads, and all. System classes are there. But these hundreds of classes which they have already developed and they have pre-compiled and given to your dot class. They have pre-compiled it. They have not given all that class as one bunch. They have arranged them systematically in the form of packages. Now you'll say, what are packages? Nothing rocket science or anything. Packages means a folder in your computer. It represents a folder in the computer. So there is one main package called Java package. Getting? And inside that, there are many sub packages. Okay. Like there is the lang package. Okay. And then in separate packages, there are related classes. Okay. Dot class. Okay. Like if it is a lang package, then we will have string, then integer, then boolean, character, thread, all those are present here. Then if we take AWT package, that is window tool. The here we will have button, then label, then text field, and so many. These things we will not learn because all these things are becoming absolute. Industry is not expecting this all things. Okay. Then we have like SQL package. Then in that all the database related are there. Net package. Then all socket programming related are there. Getting? So they have arranged it in the packages, and your task is to import that package in your program. Okay. And after importing, those classes are loaded in the memory, and those classes are available to you to be used in your program. So how you will use in your program? By creating objects. You'll create objects of those class and start using it. Getting? You'll create an object and then dot, you will call methods. So you don't have to develop all these things like util package. If there is a util package. So in util package, there are already ready-made classes provided like stack, priority queue, linked list, getting hash table, hash map. All these are ready data structures. You don't have to develop all those data. Ready, they have already made and given to you. So this is also following what? Object-oriented principle only. Packages, why? Because everything is kept at one place will become unmanageable. Getting? And when you are loading that package, everything will unnecessarily get loaded. No? Only what is needed, that much package loading is good practice. No? Searching becomes easy. Managing all that becomes easy. Getting? It's same like your as you manage everything in your wardrobes, or if you go to the libraries. I don't know. Again, I said the new generation are far away from books. So if you go to libraries in your college, they have arranged different cupboards, no? Like separate cupboard for comics, separate cupboard for magazines, separate cupboard for uh, biographies, separate cupboards for encyclopedias. And then when you enter, you ask to the librarian that I want magazine. She will redirect you to that cupboard. So you directly go to that cupboard and search what you want. Honestly, you're not wasting your time. No? Getting or no? Clear? In movies only they waste. Like if you see movies, the movies that hero and heroine, honestly, they are moving in that library, and one is seen from this side and the other side. The book is removed, and then the hero sees the heroine on that side. So all these are all imaginary things, right? In reality, it is for managing properly. Okay, and not wasting time in searching and not wasting memory in loading. Okay, so why it is object oriented? I hope you got it. And please remember, Java cannot be called pure because primitive data types are not objects. They are primitive. They are directly treated as int only. We cannot treat it as an object. Getting? But if you want, then you have to separately encapsulate it in an object of wrapper class and then use it. Getting? So therefore, we cannot call it as a pure OP. Java is a true object-oriented language. Main also resides in class. Okay. All Java program code and data reside within class. Everything within the class only, even main. Main is your entry exit. Okay. Like here I've shown an example, okay, related to this. In context of this example I showed that class first, then in that I have added data, methods, main which is going to be your entry function, from where the execution will start. The life of your application start with main and complete with main. Okay, so all this thing relates to this point that code, data, everything within a class. And Java people have developed hundreds of classes. Okay, so Java itself provides extensive set of classes for so many activities so that we don't waste time in developing the same thing again. Like I want a linked list, I don't have to make my own linked list. I need a priority queue. No, you don't waste your time in developing it. They already have provided a priority queue, a stack, a set, hash table. Getting means you need a sorted set, then go for tree set. All that we'll be learning, don't worry. Okay, so extensive classes in the pre-compiled form. They're already in a dot class form and they're arranged in the package form. And then you can use those packages by importing it. And then whatever class are there in that package, you create an object and start using it. As an example, I've shown there is a main package called Java. Then it will have many sub packages. Many more packages can be there. Few I have told. And each package contains classes. And our job is to load whichever class you need. That package we have to import. The class will get loaded. And now you can start using that class in your program by creating objects. Okay? Okay? So I hope this part is also clear to you guys. Right? So just give me quick confirmation.